Good morning, students. Very good morning. Today we discuss about a basic chapter of electricity, that is Ohm's law. Here we discuss the Ohm's law. What is Ohm's law? It states that, at first we write the Ohm's law. It states that the current is flowing through a conductor is directly proportional to the applied voltage when temperature is constant. Okay, so it states that the current is flowing through the conductor is directly proportional to the voltage of the conductor when temperature is constant. So what is the voltage? It is defined as V. Okay, so what is voltage? Voltage, its formula W by Q. What is W? W is equal to work done and Q is equal to amount of charge. W is equal to work done and Q is equal to amount of charge. So what is the definition of voltage? The amount of work done is needed to transfer a charge from point A to point B. Okay, so what is the unit of voltage? This is volt. This is volt, unit of voltage. Okay, next, what is current? Next we discuss current. Current is denoted by capital I. What is current? Amount of charge Q by time. Amount of charge flow through a conductor in a unit time. Q is the amount of charge and T is the time. So what is the unit of current? So what is the unit of charge at first? Q is equal to coulomb. And what is the unit of time? That is second. So coulomb per second is called ampere. Okay. Next we discuss the mathematical expression of Ohm's law. Now we discuss the mathematical expression of Ohm's law. So what is the mathematical expression? Voltage V is directly proportional to the current. Okay, voltage is directly proportional to the current. If we increase amount of voltage, the current is also increase. If we decrease the amount of voltage, the current is also decreases. Okay, now we introduce is equal to sign instead of proportionality. So we introduce a constant that is called R. So what is R? R is the resistance of conductor. Okay, so V is equal to IR. It is the mathematical expression of Ohm's law. So V is the voltage, R is the resistance, and I is the amount of current flow through the conductor. So we get from here R is equal to V by I. Okay. Now what is the unit of resistance? What is the unit of resistance? So what is the unit of voltage? At first we say voltage resistance is volt. And what is the unit of current? That is called ampere. Okay, so voltage by ampere is called ohm. So what is the unit of resistance? That is called ohm. What is the symbol of resistance? Ohm. This is the symbol of resistance. Clear? Now we discuss about the graph of this Ohm's law. Okay, so draw a graph. It is the y-axis and it is the x-axis. Along x-axis we put current. And along the y-axis we put voltage. Okay, it is the origin, that is 0. Now along the x-axis we put current. Suppose it is 1, it is 2, it is 3 ampere, it is 4 ampere, it is 5 ampere, and it is 6 ampere. And along the y-axis the amount of voltage, 2 voltage, it's 4, it's 6, it's 8, and it's 10. Clear? Okay. Now when at time is equal to 0, no voltage is connected, then the amount of current is 0. So when voltage 0, current is 0. Voltage 0, current is equal to 0. Now we increase the voltage, the amount of voltage 2 volt. Then the amount of current flow through the conductor, that is 1 volt. So we draw. So this is the point. Now again we increase the amount of voltage, that is 4 volt. Okay. Then the amount of current flow through the conductor is 2 ampere. In similar process, we increase the amount of current and increase of voltage. Now we introduce 6 volt. The amount of current flow through the conductor in the meantime 3 ampere. 8 volt, the amount of current flow 4 ampere. This is 10 volt and this is 5 ampere. So we draw the graph of voltage versus current. VI graph. This is called VI graph. Okay. So we draw the line. It's a straight line. This is the main point. Okay. So for a conductor, this is the VI graph. From this VI graph, we draw a triangle. We draw a right angle triangle and we get a resistance from this graph. Okay. Now draw. Okay. This is the right angle triangle. This angle is theta. Okay. This angle is 90 degree. So it is the perpendicular. And it is the base and it is the hypotenuse. Okay. From this triangle we get the resistance. Okay. It is the maximum point along the y-axis. It is a maximum point. So slope from this graph, slope is equal to perpendicular by base. P means perpendicular, B means base. So what is the perpendicular value? This is the maximum point and this is the minimum point. Maximum point value 10, minimum point value 0. And maximum B is called base. Maximum value B 5 minus 0. So we get 10 by 5 is equal to 2. So what is the value of 2? 2 is the resistance of the conductor. So we get from the slope of VI graph resistance. P by B. What is P? P means perpendicular. Along perpendicular, this is voltage, and base means this, that is called current. So V by I is equal to resistance. So we get resistance from this graph, that is called 2 ohm. Clear? So we get resistance from this slope. Okay. So now we discuss about mathematical expression and the circuit of the Ohm's law. Okay. So look, it's look like this. It's the battery. It's the battery. That is suppose 12 volt, and it is a resistance. Resistance. It's like that. Okay. It's a resistance and it is a circuit. The current flow from positive to negative direction. So current flow through this direction I, and the electron flow in this direction. We know that electron direction, the flow of electron and the flow of current are in opposite direction. Okay. So direction of current in this direction, positive to negative, and the electron flow, the negative to positive. Okay. And suppose we introduce the resistance, that is R is equal to 10 ohm. Okay, and the battery is connected in 12 volt. Okay, so now we find the amount of current flow through the conductor. Okay, so we know from the Ohm's law V is equal to I R. So we get from this circuit voltage is equal to 12 volt. Okay, and we find out the amount of current I. Okay, we find out the amount of current. What is the amount of resistance? That is called 10 ohm. Okay, so what is the amount of current? I is equal to 12 by 10. That is I is equal to 1.2 ampere. Okay, so it is the mathematical form of Ohm's law, and we consider this is the numericals. V is equal to IR, voltage 12 volt, amount of current we find out, and the resistance is 10 ohm. So we get 12 by 10, that is I is equal to 1 by 2 ampere. Okay, this time. Now we discuss about the two applications of Ohm's law. Two applications of Ohm's law. Okay, when two or more resistors are connected in series combination, that is looks like that. This is a resistance are connected in series combination. It is a battery connected in series combination. This is R1, this is R2, and this is R3. First resistance R1, second resistance R2, third resistance R3. Okay, this resistance and equivalent resistance are R is equal to R1 plus R2 plus R3 plus dot dot dot. If more resistors are connected in the circuit. Okay, when two or more resistors connected in parallel combination, this is parallel law. Okay. This is R1 and this is R2 are connected in parallel. Similarly, it is the battery, and this is the flow of current I. It is divided in two parts. This is I1 and this is I2. This is the resistance. So equivalent resistance we get R is equal to R1 R2 by R1 plus R2. Okay. Now we again discuss about numericals. Suppose it is a circuit. These two resistors, it is R1, that is 1 ohm. This is R2, this is 3 ohm, and this is R3, that is 3 ohm. This is the symbol of resistance. This R2 and R3 are connected in parallel combination, and R1 is connected R2 and R3 given resistance with series combination. Okay, this is the voltage supply battery, voltage supply, that is 10 volt. Okay, so what is the equivalent resistance of R2 and R3? We get the equivalent resistance formula: R is equal to R1 R2 by R1 plus R2. In that case, R1 is equal to 3 and R2 is equal to 3. Same, and R1 plus R2, that is 3 plus 3, 6. So we get 9 by 6. So cancel out 3 by 2, that is 1.5 ohm. So what is the equivalent resistance of R2 and R3? That is 1.5 ohm. So what is the next diagram? So it is the equivalent resistance of R2 and R3, that is we find out R equivalent is called 1.5 ohm. So R1 and R equivalent are in series combination. R1, that is 1 ohm, and R equivalent of R2 and R3 is 1.5 ohm, are connected in series combination. Clear? So now we find out the amount of current flow through this circuit. Okay, so amount of voltage 10 volt, resistance R is equal to R1 plus R equivalent. Okay, so I is equal to, we find out. Okay, so from Ohm's law, what is the formula? V is equal to IR. Okay, when two resistors are connected in series combination, what is the equivalent resistance? R is equal to R1 plus R2. R1 we get 1 ohm, that is given, and R equivalent we find out, that is 1.5 ohm. So we get 2.5 ohm. Okay, so R is equal to 2.5 ohm and voltage is equal to 10 ohm. We put the value voltage 10. We find out the value of I, and R is equal to 2.5. So I is equal to 10 upon 2.5. Now 10 by 25 into 10. So 100 by 25. Now we get 4. So amount of current flow through the conductor is 4 ampere.